You've probably seen the headlines, right? Every other week, there's some new AI model that can supposedly think. They don't just spit out an answer anymore. No, they show you their work, their whole thinking process. But here's the million-dollar question. Is any of that real? Is it genuine reasoning, or are we just watching a very, very sophisticated magic trick? Well, some researchers at Apple decided it was time to pull back the curtain and find out. So these new models we're talking about have a specific name: large reasoning models, or LRMs for short. You might have heard of some big ones, like OpenAI's One or Claude's thinking model. They're all built on this idea of generating a long chain of thought before they land on a final answer.
The theory is pretty simple, By thinking out loud just like a person might, the AI should be able to tackle more complex problems. It's supposed to make them more powerful and a whole lot more transparent. But does it actually work?
This is the exact question those Apple researchers set out to answer. In their words, are these models actually capable of generalizable reasoning, or are they just using super advanced pattern matching? Is it thinking, or is it just mimicry?
Okay, so how in the world do you test for something as fuzzy as genuine reasoning? It turns out your standard high school math problems just won't cut it. For starters, the model might have already seen the exact questions and answers in its massive training data. That's called data contamination, and it means it's just remembering, not problem solving. Plus, it's really hard to fine-tune the difficulty or even know if the reasoning steps it's showing you are any good. So, to get around all that, the researchers built what you could call a clean room for the AI's mind. They used simple, controllable logic puzzles, like the Tower of Hanoi. This way, they had total control over the complexity, and there was absolutely no way the AI could have cheated by seeing the answers before.
And inside this controlled environment, they found something fascinating. It turns out that performance isn't as simple as thinking is better. No, they discovered 3 totally distinct stages, or regimes, of performance, and it all depended on how complex the puzzle was.
First up, low complexity. And this is a surprise. When the puzzles were easy, forcing the AI to think actually made it worse. If you look at the graph, the standard model, that dashed line, hits 100% accuracy way faster. The thinking model lags behind. It's basically overthinking a simple task.
But then, you dial up the difficulty a bit, into this medium complexity zone, and the whole story flips. Suddenly, that thinking model, the solid blue line, shoots way ahead in accuracy. This is the sweet spot. This is where that chain of thought process actually helps it find the right answer.
But here's where it gets really wild. Push the complexity just a tiny bit further, and everything completely falls apart. Performance for both models just plummets to near zero. And look at that graph. It's not a gentle slope. It's a cliff. They just hit a wall. This really shows how brittle their so-called reasoning is. They can't generalize.
That sudden collapse is just bizarre, right? To figure out why it happens, the researchers decided to look inside the AI's actual thinking traces.
And this might be the biggest twist of all. Just as the puzzles get harder, the models, they start to give up. The graph on the right shows you the amount of thinking it's doing. As complexity goes up, the thinking goes up. But then, right at that point of collapse, it starts to go down. The moment the problem demands more brain power, the AI just decides to think less. And when they dug even deeper, they found 2 main ways these things fail. On the easy puzzles, the AI overthinks. It finds the right answer pretty early, but then just keeps exploring a bunch of wrong paths, wasting energy. But on the hard puzzles, it fixates. It makes one little mistake early on and then just gets completely stuck on it, unable to correct itself. So, after all of this, what's the final verdict? Can these incredibly advanced AI models really truly reason?
Well, the evidence seems pretty clear. These models are not the general problem solvers that we've been hoping for. Their reasoning is incredibly brittle. It works, yeah, but only in this very narrow band of complexity. The moment you push it into something truly new and difficult, the whole thing shatters.
And if you're not convinced, here's the final nail in the coffin. In one last experiment, the researchers basically gave the AI the answer key. They fed it the exact step-by-step algorithm to solve the puzzle, and it still failed at the very same point. It couldn't even follow a simple recipe when it got too long. So that leaves us with a pretty fundamental question, doesn't it? If a system can't even follow a recipe when things get a little complicated, is it really reasoning, or is it just an incredibly sophisticated mimic, doing a fantastic impression of what thinking looks like?